shall be starting with what we call databases. And the databases we are going to look at here is going to cut across. We're going to look at a database in Access, and then I will also be talking about some databases we use as we design our systems as software engineers and so on. I will request you to be attentive and pick up what you can, because when you understand databases here right now, you'll also understand databases in the future when you start using other database management systems. And you shouldn't be scared of the words I use, database management systems. We shall look at these things as we move on. Okay, so now the database management system we shall be focusing on mainly will be Access. So Access is a software that we use for database. Most people call it database the way it is. Okay, but it's a database management system. It's a software that we use to manage data. So without wasting time, we can simply start by looking at what a database is. Now, when we talk about a database, members, we're talking about a collection of data, and this data which is being collected should be related. Okay, so the collection of logically related data with descriptions designed to meet the information needs of an organization. Now, if you have an organization or a company, this organization deals with a lot of information. Information is flowing from one department to the other, from one office to the other. But what manages the flow of this information? What manages the flow of this information? What makes sure that the information being shared is not duplicated, it's organized, is what we call a database. So the database is that collection of logically related data with descriptions. The descriptions are those what makes up the data are what we call the descriptions. So they are designed mainly to meet the information needs of an organization. Now, what you must understand is that an organization, most organizations have what we call software management systems. Okay, those management systems look at a lot of things. In a management system, say for example, if we look at our college, Namilyango College, we have a management system. It's called a school management system. This management system is used by the students. It can be used by the teachers. It can also be used by the administrators. But these management systems can't work if the database is not okay, or the functionality won't be efficient if the database is not okay. So in order to make sure that the information system or the information flow within this school management system is efficient, we shall need to integrate it with a database management system. That is a software which we can use to manage information. Now, the way the users use this information or the way they access the system is in form of graphical user interface tools. On the screen, all you will see are graphical user interfaces, icons, pictures that you can click on. But what really manages the information, how the information is fetched from the database, how the information can be updated, how it can be manipulated in any way, is performed by what we call a database management system, which does its work at the background of the management system. So the users can look at the graphical user interface. Meanwhile, the designer who designed, or the software engineer who designed the system hides the database. You won't, as the user, you won't know what is happening at the background, how the information is passing. So these databases are very, very important in our daily activities within the business organization. Now, we have what we call a data bank. Okay, we have what we call a data bank. A data bank is simply a collection. It's more of a large or enormous collection of two or more databases. Now, within an organization, you can find an organization has more than 2 databases. For example, when you look at companies like Facebook, companies like WhatsApp, these big companies, the social media companies, most of these companies can't only have one database. They have what we call a data bank, which has an enormous large collection of 2 or more databases to store the enormous amounts of data which are being circulated all over the world. When you look at Facebook, if you try to imagine how much data is being kept within the data bank of Facebook, it is a lot of data. You as an individual, when you create an account, this account is going to be stored on what we call a database, such that when you log in to Facebook, it can be able to fetch the credentials you used to register on Facebook. So once it does that, it is able to compare them with all the other accounts it can find in any of the databases which are within the data bank, such that it can allow you to access your account. So you have to know the difference between a data bank and a database. A data bank consists of more than 2 databases which handle a lot of data. So when you look at this image on your screen, you can see there are a lot of servers here. On these servers, you can find different hard disks which are containing databases, different databases. So you have to understand that. Meanwhile, for us, if you want to differentiate this data bank with databases practically with the way we use our computers, when you're coming up with a login system, just a simple login system, say for example, let me show you something. I'm going to show you, say for example, let me just share another screen so that you can be able to see. Okay, are you able to see the browser? Are you all able to see the browser?
Yes, we can see the browser.
Okay, so if you are dealing with a small, let me just, this is something I'm still working on. Okay, if you're dealing with a very small system, say a login system, here you don't need more than 2 databases. Okay, you don't need a data bank to manage a very small system that allows a user to log in, because it is first of all capturing only 2 details: the email of the user. Okay, it's accessing the email of the user and the password. That is a small amount of data. So this you can only design 1 database. So you'll notice that the amount of data that is going to be stored using this system is small. And if it was a big thing connected to Facebook and so on, it means very many people can be logging in at the same time. But this is small, so you don't need a data bank for this. You just need a database. Okay, so that when you log in, it can redirect you to your dashboard, something like that. So for such small systems, you just need a database where you can create different tables, as we shall see later on in Access. Okay, but here but in this system I'm designing, the application or the database management system I'm using is not Access, so it will be kind of hard for you to understand, but the idea is the same. Okay, so we shall be looking at how we deal with this data in Access, but I was just showing you this system as an example of a small thing which will not need us to create more than 1 database. So now if I'm to show you the database of this small system here, it is just 1 single database called Namilyango College. It's this database. So if I create another database to handle another information and create another one, when I put all those databases together, it forms what we call a data bank, because the amount of data that I'm going to be performing or I'm going to be dealing with is enormous, like it's large. So I will need more than 2 databases to manipulate the information flow within these applications. Okay, so Let me stop sharing that one. Back to our screen. Okay, now let's move on to the next. Now that takes us to what we call the database management systems. Now, people will be asking questions, or there are many questions you'll come across asking you to define what a database management system is. You must understand that when we talk about a database management system, we're talking about a software. It is a system, a computer software that is supposed to do something connected to databases or connected to data flow in a system. So the database management systems, when we talk about them, they are software systems that can allow multiple users to, first of all, define data. Defining data is creating a skeleton. Like you are coming up with a way data should be flowing through the system. You create the data, after which you create the data, and then this data is going to be stored within a database. And then you can maintain and control access to the database by creating levels of access. Levels of access means a user who is just, for example, now when we look at the library management system for a school, the user who is a student has no authority to go and delete a book from the from the library. That is because he doesn't have the rights. But to manage these rights of how information should be accessed or who should access a certain information depends on how the database is maintained and access is controlled. Now, when you look at this diagram here, we have a database management system in the middle. The database management system is what comes in between the database and the users or the app. Okay, so now the users, to access information from the database there, they have to go through the database management system, something like Access, a software like Microsoft Access. They have to go through that to make sure that they can access whatever information they need to get here. And the kind of information they have to obtain from the database is going to depend on what the database management system is telling them to access. If you're a user, you can't access data which the database management system is telling you not to access. So this is a diagrammatic explanation of what a database management system does. It is simply a software that allows multiple users to define, to create, to store, to maintain, to control access to the database. Okay, so the user can access anything from the database, but whatever it accesses or he accesses is controlled within the database management system, which is a software like Microsoft Access. The rest of the examples of database management systems we shall look at are in the next slide. So now, there are very many database management systems that are being used by very many companies or very many software designers, people who design software. They use these database management systems a lot. Yes, Bisaso Marvin, I see your hand is up.
So there was a part on that representation where I put API.
API, okay.
What's the full form of API?
Okay, API, I hope I won't confuse you a lot because I didn't want to talk about it intentionally. Now, API is a platform. It is a platform. It is actually an environment. And the abbreviation API stands for Application Programming Interface. It is an interface or an environment where certain apps can be modified to work in a certain way. For example, when you visit a site that performs online payments, say like a site for Jumia, where you can access items and you can purchase them, and then you also are able to make the purchases or to make the what do you call it? to make the payments. You make the payments online. If you're able to make the payments online by making use of a certain form where you fill in details and money is going to be deducted from the bank from using your credit card. That the way those things interact is controlled by what we call an API. An example here you could talk about is PayPal. You've heard about PayPal. Most of you have heard about PayPal. Even now, MTN and Airtel have APIs. These APIs allows us programmers, us the developers, to integrate our websites, our systems with the banks. Okay, the way it is just something like an in-between, a middleman. When I fill in a form, and then I make a request to the bank to withdraw money from this person's credit card details, it's going to allow, okay, let me use an example. Let me use an example, a live example to explain API. I'm going to share back the screen, which has our browser. Are you able to see the browser? Are you all able to see the browser?
Yes.
Okay. So now, assuming, can I use, which platform can I use now? Okay. Let me use Adobe. If I'm to log in, I want you to understand how these things happen. I want you to understand how these things happen. Now, when I log in into this, there is a part. Now, this alone, what I'm accessing is a website that is used for design, designing logos and so on and so on. But it will reach a point that you want to access other features of this website, but you will have to pay for them before you access them. And now, for example, if I'm to, let's see, if I'm to do this, then I view plans. So here, for starters, it's for free, but then, let me see, I want something where I can be able to pay online. I want something where I can be able to pay online. It started. Okay. I don't think this will be able to work. Let me show you using this other one. I want you to understand. I want you to understand how these things work. Let me just sign into a website that I can use to explain. Okay, so now this is a platform called JotForms. It's a platform I use for creating my forms. The application forms, I created them from this. Now it will reach a part where you need to pay. It will reach a part where you'll need to pay. Now, when I go to that part for payment, just like you reach Jumia and you want to pay for something, now assuming I want to pay for this, where you have to pay for, it's going to be per month, $24 US dollars. When I say upgrade, it brings me these options. Then you can see we have two options here. You can pay using PayPal, which is now an API. PayPal is an API. It's just a middleman, which allows us to create, make purchases from this website. So when I click on use PayPal and I agree to the terms and conditions of service, it will take me now to the API itself. So now this is the API where you have to create an email. Let me just. Where you create an email. After creating an email, that email is going to be used with reference to whatever you're paying for. Any kind of payment you make will be there. So now here we are on the API. So when I fill this form asks me for my credit card or the Visa card number, the expiry date, the CSC, then the street address. When I fill this form to pay this amount of money here, $288, and then the moment I click on agree and subscribe, it is now going to give the API the ability to go to the banks which are registered with the PayPal, to go to those banks and look for the account which has an account number or the card number this, with the expiry date this, and the first name this. So it uses the information you fill in this form to go and deduct what is in the bank. That is how the APIs perform their work. But everything here is going to be accessed from a database somewhere. Your name, your last name, your blah, blah, blah. PayPal will be able to obtain, it will be able to know that this is this person's account by comparing whatever you filled here with whatever is in the database of the bank. So the API is just allowing you to make a transaction. It has connected the website here with another bank, which is having this Visa card. If your Visa card is for Centenary Bank, the bank it will be connected to will be Centenary Bank. And then you make that payment, it deducts the money from Centenary Bank, which has this account from this account, this very account here. And then it is going to transfer this money to the account of this website, of the person who designed this website. So that is how the APIs work. I don't know if it is clear enough for you, Bisaso, but that is how an API works. It is just an application programming interface. You integrate, they're just like middlemen, such that you are able to do certain things. Now, even MTN has an API. Okay, so most of them are just for middleman activities, to connect the bank and your website, to connect MTN and your website such that you can be able to perform mobile money purchases online and so on and so on. So I don't know, is it clear, guys? Have you understood how APIs now work?
Yes, it's clear.
Okay, so let's move on to the examples of the database management systems. Now, when we talk about the database management systems, like we say, these are the software systems that allow the multiple users to define, to create, to store, and to maintain, and even to control the access to the database. Now, these softwares are very many in the market nowadays, or in the world, the modern world of technology, and the one you choose to use depends on your choice. Okay, it depends on what you feel is best. But for our case, we shall be majorly dealing with Microsoft Access. Okay, then the others include Oracle database. Oracle database is mostly used by those big companies that perform or that deal with a lot of data or information. We have the Microsoft Fox Pro. The Microsoft Fox Pro was one of the first databases which were designed in the technology of computer by Microsoft. But the way they used to access data is not the way these modern database management systems manage the data. So it is an old database management system which was designed by Microsoft in the 1990s, something, okay, not 1990s, in the 1900s, okay. So it is an example also you could use. And then we have Microsoft SQL Server. This Microsoft SQL Server is also a database management system that we can use to design the databases and to manage how we can access data from the databases. Then we have MySQL, which is my favorite. It is what I normally use for my system. So the ones you decide to use for your system, it depends on which one you choose. Now, most of the Windows applications use, okay, Benjamin, I see your hand is up. Please ask your question.
Sir, yes. Like Google Sheets and Google Docs, does also database have something that is online?
Okay, now some of these things we are seeing here, for example, the MySQL server, there are some which are online, okay? There are some which are online. Even Oracle, you can use it online. They have online servers that you can use. actually, when you look at systems, modern systems nowadays for many banks and so on, they use the database, which is on a server online. So you will find a database management system like Oracle having its server online, and anyone could just go and access it to create a database. So you don't need to specify whether it's online or not, but it depends on the. Now, if I showed you, okay, let me show you back. Let me show you this again. Oh, unfortunately, I've closed my browser. But let me show you my browser again and try to explain to you. Try to explain to you such that you can understand it into details. Okay. Let me share it for you to see. Okay, are you able to see my browser again?
Yes.
Okay. So now what you should understand, Benjamin, is that this, because I'm opening it through the browser, doesn't mean it is online. The database here is on my local computer. I've created it on a local computer. I installed what we call XAMPP. Okay, I'm using XAMPP, which is a local server. It is a server. Okay, it is a local server that we can install on the computer to create databases. But in order to access it, we'll need a browser. So I'm accessing this from my computer, not from the internet. But after I'm done designing this system here, it will now reach a time for me to go and upload it onto the internet. So when I put it on the internet, I will not be using this local server anymore. It will be using a server which has been put online. I'll be using a server which is online, created for me by the hosting company. So when I host the system, the library, it's going to be, the database management system is going to be provided by the company on which I've hosted it. So there are no examples of examples like the online Google Docs, Google Sheets, and so on. Those ones, no, we can access them online also. Is it okay, Benjamin?
Yes, sir.
Okay. Okay. So let's go back to our presentation here. So these are some of the examples of the database management systems. Now let's go ahead and look at types of databases. Now, when we look at types of databases, there are two types of databases. Now, the very first example or the very first type of database you could look at or you could easily remember is the one, is the one we call a flat database. Now, the flat database consists of only one table. It consists of only one table. Now, most people could even relate this flat database to a file, a paper file, just a simple paper where you have put data and you put it in a file, okay? That is manual. You can even call it a manual database. It only consists of one table. These ones, you mostly find them on papers and 2 dimensions mostly. So when we look at the other type of databases, which is called relational databases, now this is the kind that consists of 2 or more tables. It consists of 2 or more tables. These tables are holding data of specific entities. Okay. Now, what an entity is, when you look at a database, for example, when you look at a database of a school management system, the entities are those people, those things you can find within a school. In a school, you can find a student, but a student has a name, a student has a class, a student has a year, their age, student has the height is also there. So these characteristics are for an entity of an entity who at this moment who is called the student. The student, who is our entity right now, has different characteristics of class, of name, of height, of age. So these are characteristics, and sometimes we call these characteristics attributes. So each entity will be possessing a table, because I will need to store the student's name, the student's ID, the student's home of residence, blah, blah, blah. All of those, I will need to keep it within a table. And then I will also create another table for a teacher, because remember, these are still entities within that school for which I'm designing a system. So there will also be another table designed for the teachers, but the teachers are kind of related to the students. Okay, a student can say, this teacher is my mentor. So the relationship is there. So that means there should be a way one table of the student, or one table for the student, is related to a table of teachers. That kind of relationship, when you create it, that's what gives rise to what we call a relational database. Okay, so the word relational comes from relationships. But you'll get confused when someone tells you that a table is also called a relation. So don't go into it anyway, but just know a relational database consists of two or more data tables that manipulate data by relating the tables, such that when we look for someone, a teacher, from the teacher's table, we're able to relate it to a student table. How? This teacher we have identified could be related to a student on the other table for the students by being a mentor to a student. So if I'm a mentor to a student, it means I have a relationship between this table of the teachers and the table of the students, because among the students, I have someone I am mentoring. That is something in real life how you could understand it. So these relational databases have two or more tables that can be related. Okay, an example could also be the small system I showed you for the library here. Okay, so those are the two types of database. Now, when we look at the differences between these two types, the flat database, of course, you can say has a single table. Then the relational database has multiple entities or multiple tables. Okay. Then here we represent data using a data dictionary. I shouldn't concentrate more on that. And then here we use a schema entity relationship diagrams. You'll see later on in Access that we shall be able to draw these data relationships, okay, entity relationships. Okay, and then here we find files, record fields, and characters, but here we find entities, attributes, and relationships. The attributes are the characteristics of the entities. You already know what an entity is. Like I said, within a school, you can find different entities like a student, a teacher, the non-teaching staff. All those are entities of a school. Okay, then when we look at the advantages, this one is simple to create. The flat file database is simple to create. It's easy to use, and it's also not expensive. Then on the other side of the relational databases, you'll find that it has reduced data redundancy. Reduced data redundancy, we are going to look at these advantages later on. The consistency is also better than the one for the flat database. Then data can be shared easily and so on. The disadvantage here is data redundancy and inconsistency is a lot, because each of the data is on a separate file, and you find that there is no relationship between these two databases. I mean the two tables which have been created. And then here, this one takes a lot of time to set up. That's why in companies you find there are people who are specifically kept to design the databases. Then people who design the software are also put different. That is something we see in the life cycle of developing systems. In the life cycle, we have the system analysis, we have system development, we have system design, and then we have the database management. people who deal with the database are separate. So if we are able to allocate separate people to deal with the database, it means that database takes time to set up. So you have to understand this. You'll go and get more details when you go and do your research on Google. Okay, let's move on to the next slide. Now let's look at the functions of a database management system. What is a database management system supposed to do? What is it supposed to do? Is what we are looking at as the functions. Now, the very first function of a database management system is to take care of storage. Okay, when you're dealing with the tables, you're dealing with tables and a lot of things. The database, the database management system should make sure that the information you are filling in a form can be stored somewhere in the computer storage, memory storage. Okay, so it takes care of storage. It also takes care of retrieval. How you can fetch the data from the database is managed by the database management system, just like the image we saw up there, where we had the API, the user, the app, and then in the middle we have the database management system, and then last we have the database. So it manages retrieval, storage, and management of large data sets in the database. That is the very first function of a database management system. Then the next function could be, it is used to create a database structure. Now, before you come up with a database, you must go through a database management system to create that database. Okay, you should use a database management system to create the database. So without the database management system, it will be very hard for you to come up with a database. That is why, in order for us to create a database, you first have to open Access, Microsoft Access, and then you start creating tables. So the process of creating those tables, you're actually coming up with a database. So the database structure may include the tables, the queries, and so on. And the reason why you're coming up with those structures is to make sure that you can accommodate the data that may be text, that may be in the form of numbers, it may be in the form of objects, videos, sounds, and so on. That is another function. And then the next function we could also look at is, it can let you easily add new records. Now imagine imagine there is a library where you're supposed to access some file. Okay, we have, okay, for example, if you go to college, our college is having a manual database of keeping books. Now you can imagine when you want to access a book from the online, from the library, you have to go through the librarian. You first sign some books there. You sign somewhere in a book. After signing, now you also have to look for that book. You look for it. When you find it, sometimes you find what is not, what is close to what you want, but it's not what you want. So you are wasting a lot of time to just get something. But with a database management system, all you have to do is search, type, search. So let me share my screen again to explain. Let me do to explain. Back to our side here. Okay, let me use this. Now, for example, I'm looking for a book. Instead of going to the librarian, instead of going to the to sign in a book, then looking for the book, it is taking a lot of time. But with the database management system, all I have to do is search for a book. Okay, chemistry. Once I search for it, it fetches for me the book which is available. So I can easily find a book. I can find a record easily by using a database management system. So there it gives me that function. Okay, it gives me that function. Okay, so that is a function of a database management system also. Then we also it also allows us to organize records in different ways. Okay, you can organize this data in different ways. Data connected to students, put them separate. Data connected to teachers, separate. You see, there's that order in which data is, or records are organized. Okay, then also when you're retrieving, you can actually sort this data in some order. Okay, this all comes to be part of the organization, how organized data is in the database. Then the database management system also can help us to locate specific records. For example, there I searched for specifically chemistry books. So it's going to fetch for me every chemistry book within the database, which makes it easy. It also eliminates duplicate data, say by editing, deleting, and retyping. Okay. Then we can also use it to create relationships between tables, as we shall see later on in Access. You can ask questions about your data. You can also get answers using queries. Okay, so you can ask a question about the data, then it will generate for you queries. For example, if you ask the database management system to fetch for you all students who were admitted to the school between the years 2019 and 2020, it answers that question by fetching the student details within that year bracket, and it displays it for you through a query. Then it can also be used to create data entry forms. You can create forms by using this data management system. Then we can also create professional, good-looking reports. All these we shall look at how we can practically design, starting with the table, going to the forms, creating a report, and so on and so on. We shall see all these functions practically. Okay, so let's move on to the next. Let's look at what we call the now advantages of databases, or advantages of the database management systems. Okay. Okay, so this is supposed to be advantages of database management systems, not databases. Let me just go ahead and change that such that we have order. Okay, it's advantages of a database management system, DBMS. Okay, so I've just changed that. So when we look at the advantages, I told you there's a difference between the function and the advantage of something. When we talk about the function, what does that thing do is what a function means. Then when we talk about the advantages, what do we gain? What are the benefits of using such a thing? So the advantages of a database management system is actually just telling us about the benefits of using a database management system. So these advantages come in very many ways. Okay, starting with sharing of data. How do you benefit from sharing that? You are able to share data among each other. For example, in a school, okay, you can send information from the bursar's office to the headmaster's office, so long as there is a database management system linking these two. Okay, so the benefit is you can easily share data among different users and among different applications. That is the first advantage. Data persistence. Data exists beyond the scope of the process. If I've designed a system to manage school details or a student's detail, that information is going to stay in the database until I come and remove it. That is what we call data persistence. Data being able to exist beyond even the time we needed it. Okay, I needed to fetch information about a student called Benjamin, who is in Senior 5 Science A. After fetching that data, it doesn't mean the data is going to be lost. That is going to stay. That same data is going to continue staying in the database until I remove it. That is data being persistent. Then we have data security. As we design these systems with the databases, we have to make sure that this data in the database is protected from unauthorized access. from unauthorized access or unauthenticated access. So we can specify this, or we can make sure of this by coming up with what we call passwords and usernames. For example, the login system I showed you, it is to maintain what? It is to maintain what we call security, okay? Because now, when we don't ensure security, within the system, it becomes hard for someone. It actually becomes hard for someone to control who accesses which data. For example, here now, if I log out, this is a way of implementing security. This ensures that it is only the administrator that can access a certain information. That is why he has to log in using his email and the password. If it is a student or a teacher, the teacher should first log in to make sure that he can access his data. Okay? If it's a teacher, a student, the student has to also log in order to access the student data. And you'll notice that what a student can be able to do can be limited by making sure that it only fetches the specific data for the students to access. You can't tell a student to start uploading books into a library, an online library, because that is not the work of the student. So this kind of levels of security is manipulated using what we call the database management system. That is data security. And then we have what we call data validity. The data we deal with is always valid. Okay, when you fetch data, I searched for chemistry books, I received a valid data. And when we talk about validity, how it is supposed to meet a certain need, or how right it is. Okay, how right is the data? If I search for chemistry, I shouldn't get biology because I didn't search for biology, I searched for a chemistry book. So when you use a database management system, it also caters for validity. When you search for chemistry, it fetches chemistry from the database. That is data being valid, correct, the correctness, okay? And then data integrity is to do with, both the correctness and the consistency of data, okay? Then we have consistency of data. When the bursar fetches information about Benjamin, it should be the same information fetched by the headmaster. That is data consistency. Data is consistent. If the name Benjamin is starting with capital B, it should be like that all through. Anyone who tries to access the information of Benjamin from the database should get the same exact data when compared to a different person who fetches that information. So that is to do with consistency of data. Data is consistent. That is an advantage. Because now when that is consistent, you have no doubt. You always have some trust in the system. Because you know, whether so and so comes and does what, you'll be able to know that this person is going to see the same data I saw. There's that kind of trust in the system that develops because of data consistency. Okay. Then, like I told you about data integrity refers to both the correctness, how correct is this data, and how consistent is this data. When you put these two points together, consistency and correctness, it gives rise to what we call the data integrity. Okay, correctness being free, correctness meaning being free from errors, while consistency is having no conflicts among the related data items. That is what we call data integrity. And then we also look at large data storage. Like I told you, companies like Facebook, they are able to store large amounts of data because they are using what we call a database management system. So the need for storage of large amounts of data is satisfied by making use of a DBMS. Okay. So these advantages are very, very important. You can feel the benefits you get from the database management systems when you use them. Non-redundancy. When you're looking at database management systems, you know, there are times when someone tries to enter the same data twice. For example, you are trying to register on Facebook. You try to register on Facebook, but you want to use the same username and the same, you are putting in the same details okay, let's use this example. You created your Facebook account, okay? You enter the details, your phone number, your names, your year, date of birth, and the number, the password, and so on and so on. Then later on, your sister comes to you, your young sister comes to you and tells you, please create for me a Facebook account. You start creating the account, but you're entering, if you start entering the same details you entered when you were creating your own account, you will not be able to create an account because the database management system will alert you that this information you're trying to put inside there is already existing. Okay? So data redundancy is controlled. It eliminates duplication of data in the same container or in the same database. That is how we benefit. So there's also what we call data independence. Both the data and the user program can be altered independently. What do I mean when I say this? I told you what users see when they are using a system is not what is happening at the background. For example, let's go back to this system here. Now, what I'm a user, I'm just searching for a book, chemistry. I am searching for a book, and by the time I click on the search, I'm clicking here. The way I am doing things on the screen here is not the way things are happening at the background of this system. That is the independence. Okay, that is what we call independence of data independence. At the background, the database is performing its activities independent of whatever is happening here. Okay. Okay, so now I can search for this and I get a detail. So what I'm doing here is independent. How data is performed here, how data flows on the interfaces here is different from how data is moving at the background in the database. That is what we call data independence. Are we together? Is it clear, members? Do you have questions about the advantages? Is there any question about the advantages and functions? Are we okay? Are we moving at the same pace?
Yes.
Okay. All right.
So the point of redundancy.
Redundancy. Someone wants. Okay, you want me to re-explain redundancy? Okay. Just understand it in this way. Redundancy is if data is redundant. The word redundant means duplicates. You have entered Benjamin's details using a form, and then you come back again and re-enter the same details in the database. There will be two details now for Benjamin. I'm using Benjamin as an example because his name is always easy for me to remember. Now, I've already inserted. Okay, let me see if I'm to do this. Okay, if I'm to use this form. This form is connected to a table. I enter here the name Benjamin. I put here a class, senior 5. I put the author of the book I'm trying to request for. Let's say he's called Barry. Then choose level, it's a level, the description, okay? This book is amazing, okay, something like that. I will submit this book by clicking on submit request. Once I click on submit request, the data is going to be dumped into the database. Now, I've already submitted this detail, but someone else comes and also accesses this same form and enters the same details he have entered and submits it for the second time. There now we shall see data becomes redundant in the database. It becomes redundant. Now, why we say a database management system controls redundancy is that when you try to submit this for the second time, the same data the second time, it will generate an error telling you that this data already exists. So there it is avoiding data redundancy. Are we clear now? Is it clear now? Is it clear? The person who asked for the explanation. Yes? Or you're still having some queries? Okay. Let us continue. Let us move on with now. Now that we have looked at the advantages of a database management system, let's look at the advantages of excuse me, I think there's some misunderstanding here. Let me see. Okay. Then let's look at the disadvantages. We looked at the benefits. We looked at the benefits of these database management systems. We have understood them. We talked about non-redundancy, blah, 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 and so on and so on. Now it's time for us to look at the disadvantages of database management systems. So when it comes to the disadvantages, guys, you'll have to understand that as you're using these database management systems, there are certain things associated with them that are not favorable, okay, that are not favorable as you are using them, or before you use them, or after you use them. Those unfavorable things we are looking at are what we call the disadvantages. The very first point here we could talk about is complexity. Things when we talk about complexity, it's something which is hard to come up with. A database management system is hard to use at times. That is why you find students in different schools learning Access, such that they can easily understand it with the help of a teacher. But you'll find most students even have issues when it comes to understanding how these things are used, or the database management systems are used. It is complex to use. That is the first disadvantage. Okay. First of all, designing them or even accessing this database management system sometimes it is costly. Okay. And it also takes much time to develop. That is why we have different groups of people in companies to handle databases, because of the complexity of a database management system. Okay, so you should be able to have the skills in order to use them. Then the other thing could also be about complexity is that, leave alone the database management system itself, sometimes using these DBMSs requires you to use certain sophisticated software programs that may require special hardware. Okay, sometimes they require you to buy special hardware in order to use them. That is part of the complexity also. Then there's also need for, there is need for substantial conversion effort. Now, changing from a traditional file-oriented system to a computerized database system can involve large scale of reorganization. For example, you have your company. Your company was started by your dad in the late 1980s, okay? And by then, information or data was kept in paper files, okay, which were kept in shelves. You enter a library, which has been there since 1902, our library. You find books are kept in shelves, hard copy. There are things you find are in files, paper files, tangible. Imagine that. Then after some time, you become the headmaster or you become the manager of your of that company your dad started in those days. But then things now are different. Things now are different. You need computers to run companies. Now you have to change from the old ways of storing files or data to the computerized ways of storing data. Now you can imagine all the stress you have to go through to convert from computerized data to from the manual data storage to the new ones which are computerized. Filling all those data into the database, it will need you to even hire certain secretaries to come and type. Okay, so the conversion effort is substantial. It is hectic. Okay, it is hectic. It will involve you to completely change the way things are run within your company, such that you can ensure that data is kept in computers using the database management systems. That is a disadvantage. Okay. The third disadvantage is organization security. You see, these things can be secure, but they are not highly secure. Now, in a company like a school, we have several departments. Each department having its own ways of accessing the database. So it is not always a sure thing that the organization information in the database is secure, because the database may be compromised. Since a database is used by many people, very many people are using the same database. Very many departments are using the same database. Okay, so you'll find some people will want to try to hack your system or your email login credentials and so on to access, or someone else can later on know your password and your username and can access your files. For example, from the Basar's office, let's say the procurement officer gets to know the username and the password of the Basar's account. There is insecurity. It means the procurement officer will be able to access files from the account of the Basar. So there's that kind of insecurity which arises also. Then they are difficult to thoroughly test and audit errors. So that's why we always talk about updates and upgrades. You'll never find a system that is 100% okay, because as computers keep on evolving and systems keep on evolving, the way the systems appear or the way the features work also keeps on changing. So sometimes to go through the errors and to test, it is very difficult, because as you solve another error, another is being created because the way you're solving this first error is not okay. So it requires thorough testing and auditing, but because of these errors, it becomes difficult. Then the initial expense of starting, of creating a database using a database management system is high. You have to pay the people who are designing the database. You have to buy software that can access the database. Sometimes some of these database management systems have to be paid for before you start using them online. So the initial starting is normally expensive. Okay. it's normally expensive to start. And then it also requires special skills to handle. It is very hard for people who don't have the skills to handle database management systems to handle them. When you don't have those skills, you can't do it. It's like you who knows how to play football only, then you cross over for basketball. You'll find yourself playing nonsense in the court. So sometimes you need the skills first before you start using something. So these database management systems require special skills to handle. Being complex and enormous, the skilled personnel has to come in to make sure that you can use this database management system for your companies and organizations. In fact, maintaining the DBMSs alone is also not easy if you don't have the skills. And then we also have what we call vulnerability, something being vulnerable. If we talk about something being vulnerable, it means you are prone to attacks from the external forces. If your home is not fenced, then your home is vulnerable to thieves. So the vulnerability of data in this case of the database management systems is in the line of data being exposed to software and hardware failures, data being exposed to sabotage, data being exposed to theft, to destruction, to virus attacks. That is what we call vulnerability. So these database management systems sometimes are vulnerable because they are exposed to these threats. Okay, theft, destruction, virus attacks, hardware failures can come as a result of fire outbreaks. Okay, so all these are vulnerabilities. But there are ways you can avoid these things. How? You can keep on backing up your data in a different in a different hard disk. Okay, keeping up backing up data, is a way you can avoid these vulnerabilities from affecting you. Then we have what we call routine backups. Routine backups means you should always be backing up your data. If you don't back up data, the moment you lose it, that is it. The moment you lose the data, in case of any kind of threat or any kind of vulnerability, you lose it forever. So using these database management systems requires you to always be keeping backups of your data. That means if there is a database for the school, there should be a backup of this data, because after students leave, a student will come back to the same school where he was studying 5 years or 50 years ago to ask you for his report card of some year. Then if you have not been backing up, you can easily fail to get this person's information from the database. So you have to always be backing up. So when you always back up, it's kind of inconveniencing. It inconveniences the person who is doing the backup. Then it's also tedious and expensive sometimes, because you need to buy the hard disks to store the data that you're trying to back up. So those are the disadvantages of using database management systems. Is it clear? Is everything okay? So for today, I want us to stop here. For today, I want us to stop on the disadvantages of database management systems, such that the next time we meet, we shall look at the disadvantages of using the flat databases.